Okay, everybody, this is a video to show you how to do the square root of 25.3 using differentials to, and by the way, we're estimating it. When they say we're estimating around your answer to 4 decimal places, they don't want you to plug in the square root of 25.3 on your calculator because you will get it wrong. You have to estimate this the way Newton estimated it without a calculator back in the day. He only estimated it. He didn't find the exact answer. It was kind of close. So I'm going to do this one, and I'm going to do you remember what was on the last test? Was it? I'm going to do this one. I'm going to do both of these, okay? So the formula for this is the function plus the derivative of the function times dx. So this is the formula. By the way, our parent function, this f, this function is, I'm looking for room. Let me move this over. Our parent function is this. If we're talking about the square root, this is the parent function, square root of x. Another way of writing it is x to the 1/2 power. So this is our function, and I want to take the derivative of our function. The derivative of x to the 1/2. Well, let me put f. That's not the derivative yet. We're going to have the derivative here. Is 1/2 x to the negative 1/2. You bring the 1/2 in front, and then you subtract 1, and this is the derivative. So we're going to use the formula they gave us. Our function. I'm going to write here. Wait, let me erase that. Our function, which is the square root of x, plus the derivative of our function, which is 1/2 square root of x. Do you see this negative brings the x down to the bottom, and x to the 1/2 power is the square root of x. And then you have to, don't forget this dx. This is the change from a known factor that we have. That's the change from a known factor. So this is the formula then laid out. When we do the square root of x, you have to write down the original function and then take the derivative of the original function like I just did. So if you look, this now turns into, let me change my color. This now turns into the original function plus 1/2 square root of the original plus dx. So, and 25 is our original function here. That's why I put 25 in there. I'm sorry, I should have just put x. But 25 is what we know. Do you see? 25 is what we know. So I put 25 in here. The dx part is the 0.3. It's 0.3 more than 25. That's the change from 25. 0.3. And another way of writing 0.3, by the way, is 3/10. I'm just putting it right there. Because Newton did this using no calculator. And this is what they wanted to use Newton's method. That Newton did this without a calculator. And the reason why we have a plus here is because it's 0.3 more than the original function. Do you see? We're adding, we know the square root of 25 is 5. We know that. But we're going to add more than 5 because 0.3 is more than 5. So we're adding that. And we're going to add 1/2. This is 5. And then we have 3/10. Do you see? all this is multiplied together. This is how Newton did it. 1 times 3 on top is 3. On the bottom, we have 2 times 5 is 10. 10 times 10 is 100. And when we do this, we get 5.03 as our answer. I mean, even if you take it to 4 decimal places, they said take it to 4 decimal places, that's what you get. Hopefully I did that right. It looks right. 3 over 10, 25, which is 5, 10, and 10. Looks good. So if you, I mean, so that's the answer, 5.0300. If I take the square root of 25.3, I get 5.0299. Do you see how close it is? The actual answer in the calculator is 5.0299. But Newton didn't have a calculator. He did this all just like I did here, using fractions and decimals and dividing it out. So when you put this answer down, you're wrong. I know you used a calculator. You have to put Newton's method down. It's an approximation to 4 decimal places. Okay? So we're going to do the next one now. It's the parent function. We don't know the square root of 24, but I do know the square root of 25. So we're dealing with the square root of 25 still. I'm going to use the same formula over here. I'm going to just put this in a different color. Let's do it green. The formula is square root of x plus 1 over 2 square root of x dx. And we're going to use 25, the square root of 25, and then we're going to put the 25 in here, 25 in here, and then the dx. We're 0.5 away, so I'm going to put 0.5. Another way of writing 0.5 is 1/2. However, it's 0.5 away from 25. You have to change this to a minus because it's less than the square root of 25. You're subtracting the, this is the square root of, this is 5, square root of 25, but this is less than the square root of 25, right? Square root of 24 is less than the square root of 25, and it's less than by 1/2. So this is the way you set it up. 5 minus 1 over 2 times 5 times 1 over 2. Do you see square root of 25 is 5? So you get 5 minus 1 over 2 times 5 is 10 times 2 is 20. So the answer to this is 5 minus 1 over 20. And 1 over 20 is 5 minus 1 divided by 20. And you get is 0.05. This is 0.05. So you get 4.95 as the answer, as the approximation to the square root of 24.5. If I put the square root of 24.5 in my calculator, I get 4.9497. 4.9497 to 4 decimal places. Do you see how close Newton was without even using a calculator? He could find the square root of any number just as long as he knew the square root of a given number, like the square root of 25 is 5, the square root of 36 is 6. So he could have found that, he'd find the closest number to that and use this formula, and this is what he ended up with. So does that make sense, Hannah?
Yes, it does.
Okay, so you use subtraction when you're less than your parent function, and in this case, the parent function, the closest thing that I do know is the square root of 25. Same way here, but this is less, so you use the subtraction here.
Okay.
Since it's more than the square root of 25, we use the plus here. So that's the difference. And quite a few people got that wrong on the test. I know that was in the homework. I know problem similar to that was on the homework. I'm going to say more than half the class missed that problem. Hopefully, they won't miss it on the final. However, the final, there's a little twist to it. You, I promise you, it's going to be a little twist, but it's the same concept. It's the same concept. Just as long as you're able to take the derivative, like we did up here, you know, I mean, you don't even have to show your work. You just have to type in the answer. And I think that's what people did. They typed in the answer, but they plugged it in their calculator. Thought, yeah, this is the exact answer. I want the approximation the way Newton did it. I don't care. I don't need to see your work. It's a no work test. But if you don't do your work, you're going to get the wrong answer. All right, let me hit stop recording.